Today we're looking at something called recursive rules and iterates. So we have a couple definitions we need to get in our notebooks. First definition is for a recursive equation. That is something that uses the previous answer of a sequence to get the next value. When you write a recursive equation, you need two things. You need to tell me what the next term is, and you need to tell me what the previous term is. So the notation we're going to use for next term will be a sub n, and the notation we're going to use for the previous term is going to be a subscript n minus 1. And we always have to have a start number. Anytime you write a recursive equation, you need to tell me where you are starting. That start number is going to be identified by the term a1. Here's a very simple first example. 1, 4, 7, 10, so on and so on. We want to try to write the explicit equation, and then we want to write the recursive equation for this. So to be able to do that, we need to know what kind of sequence this is. Is it arithmetic or is it geometric? So if you use the rules that we've talked about, looking at second number minus the first, third number minus the second, do you get the same thing? 4 minus 1 is 3, 7 minus 4 is 3, 10 minus 7 is 3. So yes, this sequence is arithmetic. If it is arithmetic, then it follows the equation a sub n equals dn plus a sub 0. I can then write my explicit formula. Remember, when we get the a sub 0 term, we go backwards and find out where it came from. If we go backwards 3, this came from negative 2. So my explicit formula could be written as a sub n equals common difference, which is 3, 3n, and what did it come from? Minus 2. That's the explicit formula. Now, to write the recursive equation, remember we need to have two things. We need to know, where does this thing start? You always have to tell me where it starts from. The starting point is a sub 1, not a sub 0, a sub 1. This starts at 1. Then, how do you get the next equation? The notation for next equation is a sub n. My next equation is always found by finding the previous answer. Previous answer notation is a sub n minus 1. And what am I doing to every previous answer? I am adding 3. So the recursive formula, two parts would be a sub 1 equals 1, and a sub n equals previous answer plus 3. And just see if that makes sense. I start at 1. If I do 1 plus 3, I get 4. Take that new previous answer, 4 plus 3, I get 7. Take that previous answer, 7 plus 3, I get 10. Yes, we're on the right track. 32, 16, 8, 4. I want to write the two equations, both explicit and recursive. First, I need to know what type of sequence this is. Well, if I try to do my backward subtracting, 16 minus 32 is negative 16. 8 minus 16, negative 8. Not the same. This is not arithmetic. But if I do division, 16 divided by 32, 1/2. 8 divided by 16, 1/2. 4 divided by 8, 1/2. So this is a geometric sequence. My format for geometric, a sub n equals first term times common ratio raised to the n minus 1, which means I will have a sub n equals first term, which is 32, times my common ratio, which is 1/2, raised to the n minus 1. There's my explicit formula. My recursive equation, I need two parts, remember. Where is this thing starting? 32. A sub n will be equal to my previous answer. Previous answer is always notated with a sub n minus 1. And what am I doing to every previous answer? I am multiplying by half. A sub 1 equals 100, a sub n equals 2/5 times a sub n minus 1. This is a recursive formula. It's starting at 100, and then I take every previous answer and multiply by 2/5. Can you write the first 5 terms? Well, my first term obviously has to start with 100. Then I'm going to take 100 and times by 2/5. Then take that new number and times by 2/5, and so on. There's a very quick and easy way we can do this on our calculators. And it has to be done in a graphing calculator. I'm not sure if it would work on just a scientific. So if I pull up my calculator, I'm going to type in the number 100, and now you hit enter, so it should show up twice on your screen. Now, what are we doing each time to our previous number? We are multiplying, hit the times sign, multiplying by the fraction 2/5. Close my parenthesis, hit enter. There's my second term. Now, all you have to do is hit enter again, and again, and again, and you have your first 5 terms. 100, 40, 16, 6.4, 2.56. Let me pull back my screen. We had 100, 40, 16, 6.4, 2.56. Those are the first 5 terms. Let's try that again with this one. My first term, a sub 1 equals 8. My next term, a sub n, will be found by taking the previous answer and adding 22. Write the first 5 terms. Well, we know it's going to be 8, comma, 8 plus 22, then take that number plus 22, and so on. Let's go back to our calculator. Start with 8. Make sure you hit enter. Now, plus sign. Hold on a second. I got to erase that. Okay. Plus sign, 22. Enter. 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 That should be 5 terms. 8, 30, 52, 74, and 96. Next example we're going to do is a word problem. You'll find this on page 829 in your book. So if you have your book handy, otherwise I'm going to read it here as well. A music service initially has 50,000 annual members. Each year it loses 20% of its current members and adds 5,000 new members. Okay, so it says that we start with 50,000 people. It loses 20%, but it adds in 5,000. How can we write a recursive equation for this? Remember, your recursive equation has to have 2 parts. I need to know where to start. Well, my first term, obviously, was 50,000 people. But what am I doing to that for my recursive piece? It says that we're losing 20%, but we're going to add in 5,000 every year. Anytime you have a multiple operations going on, you always want to do the multiplication first. The last thing you're going to do is add in or subtract out anything. So I'm losing 20%. I'm going to take every previous answer, a sub n minus 1, and multiply by something. Well, here's where you have to be careful. If you're losing 20%, I need to know how much I'm keeping. So if I'm losing 20%, I'm keeping 80% of my original. So I need to multiply by what I'm keeping. I'm going to multiply by 80%. After that, I can add in or subtract out whatever I need to. They say that we add in 5,000 every time. So I'm going to do a plus 5,000. So this recursive equation actually has 2 pieces. Obviously, we have the first number, a sub 1 equals 50,000. And then the second part, a sub n equals previous answer times 0.8 and then plus 5,000. At the start of the year, we had 50,000. The question, how many people are we going to have at the start of the 5th year? And then, what does the population stabilize at? In other words, if we could hit what's called an equilibrium point, sometimes it's called a maintenance level, we want to know what that level is. So we can go to our calculators. Remember what we need to do. We're going to take previous answer times 0.8 and then 5,000. So we'll go to our calculator. We're starting with 50,000 people. Enter. We're multiplying by 0.8. That's how much we're keeping. We're keeping 80%. And then we're going to add in 5,000. Do both commands at the same time. Now hit enter. This will be the number at the start of the 2nd year. So remember we said at the start of the 1st year we have 5,000. At the start of the 2nd year is 45. Now you need to count every time you hit the enter button. Start of the 3rd year, 4th year, fifth year. At the start of the fifth year, 35,240. Now, what's going to happen in the long run? If I keep doing this over and over and over again, you can do this really quick on your calculator. Just keep hitting enter, 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 enter over and over and over again. And you're going to see that eventually this will go no lower than 25,000. It's going to take a long time for this, but if you're on your own calculator, you'll see it a lot quicker. It will never go below 25,000. That point is called the equilibrium point. You'll also see some questions in your book will say, in the long run, what happens to this population? Never going lower than 25,000. Okay, so in the fifth year, if you can remember, we said we had 35,240. And then what's the population stabilize at? 25,000. Let's try one more of those. A mosquito population in a controlled lab starts at 500. Each day 100 are hatched, but 85% die. Write the recursive rule. How many are there at the start of the fifth day? And what happens over time? In other words, where does it stabilize, or what's the equilibrium point? So we've got a starting number of 500 mosquitoes. Our recursive rule, a sub n will be equal to previous answer times by. Be careful again. It says that 85% die. That's how many we are losing. But we need to always multiply by what we are keeping. You're keeping only 15% of the mosquito population. So we're multiplying by 0.15. But then also 100 are being hatched. That's being added into our population. So I'll add in my 100. Remember, multiply by the value first. The last thing you're going to put in is the plus or minus value. Then we can go ahead and go to our calculator. My calculator doesn't want to pull up right now, so you guys will have to do this one by yourself. Sorry about that. All right, so remember, when you go to your calculator, type 500, hit enter, then times by 0.15 plus 100, enter, 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 enter. You want to do that 4 times. So that will tell you what you've got at the start of the fifth day. Hopefully you're going to come up with 117.8. Now, keep hitting your enter button over and over and over again. Are you seeing that it is approaching and never going over 118? That is your stabilization point or your equilibrium point. All right, the last thing in this section is very easy. It's called iteration. Iteration means to repeat over and over again. What we're going to do is the repeated composition of a function inside itself. They're going to give you a function rule like this one, f of x equals 4x minus 3. They're going to give you an x sub 0, which is a starting point. They're going to give you a value. We're going to plug that in, and that's going to give us what are called iterates. So we're going to take the first number 2. We're going to plug a 2 right here. 4 times 2, 8. 8 minus 3, 5. That's the first iterate. Now you take the 5 and plug the 5 in right here. 4 times 5 is 20. 20 minus 3, 17. That's the second iterate. And then do it one more time. 4 times 17 minus 3, and we get 65. These are the first 3 iterates. This starting x sub 0 number is not included in the iterate. It's what you use to come up with the first iterate, so be careful with that. Okay, one more very quick one. X sub 0 equals -1. We want the first 3 iterates. Take -1 and put it right here. -1 squared is 1, minus 5. -4 is the first iterate. Now plug in -4. -4 squared is 16. 16 minus 5, 11. And then plug in 11. 11 squared, 121 minus 5, 116. And those are the first 3 iterates, not including the -1. That's the 0 value that we use to come up with the first iterate. Okay, that's it. Recursive rules and iterates. You are now ready to go ahead with this last piece from section 12.5. Good luck.